Okay, 3-7 is a review section to get us ready for 3-8. So we are looking at 3-7 equations of lines in the coordinate plane. First thing we're talking about is slope. Again, slope, represented with m, is rise over run. Your rise are your y values, so you're subtracting your two y values, putting it over your x value. And that's when you're starting with 2 points. Sometimes we're starting from the graph when we get our slope. So it just depends on the situation. So we're going to start out first, though, having 2 points. So I have my point -8, 3 and -11, 4. If I go through with my y's and start with 4, I subtract 3. Then I have to go back to -11, and that's why we had these subscripts here. This is 1 point. So whichever point you start with, you have to go back to it for your x values. So 4 minus 3, -11 minus -8. Make sure you are subtracting that -8, and that becomes a plus. So 4 minus 3 is 1. -11 plus 8 is -3, so you have a -1/3 slope. Not sure if the book's going to be picky. You can put that negative in front of the fraction. It could go on the denominator or in the numerator. Not sure which way they're going to want it. So if we have a graph given to us, and the graph has 2 points, this is at -2, 1, 2, 4. We could go through and do the same thing, or I can go from this point up or down, always to the right to the next one. So this one I went up 3, to the right 4, so I went up 3, and I went over 4, so I have a positive 3/4 slope. Just to remind you, if you are a vertical line, it is an undefined slope, because you can't divide by 0. Your x's stay the same, so they would be 0, so it's undefined. When you travel from left to right, it's going down. It's a negative slope. I'm hoping these colors are turning out. So this one's bright red, and this one's blue. The other two are black. I can't tell it on my screen. If you're a horizontal, that is 0 slope. Your y's are the same, and so they would be 0, but you can take 0, divide by a number, and that is 0. If you're going left to right and you're rising, that's a positive slope. So those are things to keep in mind too as we're going through this. So there's 2 different forms of linear equations that you've dealt with in algebra. The first one is slope-intercept form, where y equals mx plus b. M is your slope, b is your y-intercept. So if you have an equation, and it is y equals -2/3 x plus 6, we always start with the y-intercept. So we go 0, 6, plot that point. Oh my goodness, I cannot speak. And then we'd go down 2 over 3, because that's what our slope says, -2 over 3, down 2 over 3. And when we've gone down 2 over 3, now I connect those 2 points, making sure that I will hit the next spot. That goes down 2 over 3. Put my arrows at the end, and I have graphed the line. The second form of linear equation is point-slope form. With point-slope form, y minus the y sub 1 equals the slope, m, and then your x minus x sub 1. The y sub 1 and x sub 1 is the point you're given, and you're given a slope. So if they give you the slope is 1/3 and it passes through the point 3, 3, we just plug it in. The y value was 3, the x value is 3, slope is 1/3. We're done. We have written the equation of the line. If we are given an equation of a line that says we're given the slope of 3, a y-intercept of 6, it's easiest not to put it in point slope. It's easier to put it in slope-intercept. So we go y equals the slope of 3x plus the y-intercept of 6. And we have the equation of our line. So sometimes they give us a problem and they say they want the line that passes through two different points. So negative 4, 4 and 2, 10. Well, if I look at just the names of the two types of equations, we had slope-intercept, point-slope. Both of them talk about slope. So that's a reminder, whenever you're coming up with an equational line, you start with the slope. So 10 minus 4, 2 minus negative 4. So 10 minus 4 is 6. 2 plus 4 is 6, so my slope is 1. And now I can put it in my point slope. I have the point of 4, negative 4. Sorry, negative 4, 4. I said my x and y backwards. And a slope of 1. So if I simplify the right-hand side, the y minus 4 stays the same, but we had to have a 1 times x plus 4, which just gives me x plus 4. If I were to put that in slope-intercept, I would find my slope, which was 1, and then I put a point in to the equation. So I put in the negative 4, 4, negative 4 for the x, 4 for the y, and then I'd solve. So negative 4 plus 4 is 0, add 4 to the other side, and get 8 for my b, and then I write my equation, y equals the 1x plus 8. And if I look back at this equation, if I add 4 to both sides, I have y equals x plus 8, so it is the same equation. And if I'd use the other point of 2, 10, put in 2 for x, 10 for y, I would have y minus 10 equals x plus 2, add 10 to both sides, and I'd have y equals x plus 8. So they don't specify which form of the equation you're supposed to write, if it's supposed to be slope-intercept or point-slope, so it's up to you of whichever one you want. And again, if you use point-slope, you can use either point. With the slope-intercept, it doesn't matter either which point you put into it. It will come out the same. So that is all your notes for this section.